All right, so tonight is session 3, and agenda, going to do a curriculum review or overview. We just want to go over the topics that have been covered and will be covering in the next few weeks. I'm going to do a quick recap. Then our primary goal tonight is looking at Python collections, and then we're going to dive right in and look at some Python code. And then we'll finish up with some next steps and Q&A. A lot on the plate tonight, so I'm going to keep it moving. And as we've posted a link to the Discord community, so please join Discord with any questions. If you run into trouble, that's the place to go to get help. All right, so curriculum overview. What are we covering? This is first half. Number 1, you should have installed Python on your computer and verify that it's working. Next, you should have installed VS Code. That's the cockpit. That's the critical environment that we'll be using throughout your coding. And it's not just for doing Python for these sessions, but this is if your interest is to become proficient in programming, VS Code is definitely a skill that we recommend that you have under your belt. And it's going to go a long way in the long run for you to become familiar and become an expert programmer. Then 3, we did a little bit of this, just how to navigate in the VS Code environment. And each session hope to show you a little bit more about VS Code, but that's something also that you want to start practicing and get familiar with is how to use VS Code. Okay, that's basically the environment. 1, 2, and 3 learning objectives are about the environment that you'll be working in. And then we looked at the session 1 before last week, the Python interactive shell. Now, basically, there are 2 modes in which you'll be working with Python. Python interactive shell is where you can give commands to Python one at a time and get an immediate response back. You'll use that occasionally. It's good to know it's around underneath the hood. But the primary mode in which you'll be working is to write Python programs, also called Python scripts. And we looked at a little bit of that. So where we should be is you should have know how to write a very basic Python program, even if it's just 1 or 2 lines. And that was learning objective 5. And last week we covered primitive objects and operations. And I'm going to do a quick review of that tonight. But that's kind of where we are. Looking ahead, tonight we're going to look at Python collections. I'll define what they mean. We also will look a little bit at indices and slicing. This is really fundamental part of Python and actually most languages. Whenever you have a data structure of a certain type, knowing how to access data structures using indices. It's not the only use of indices, but you'll see in action a little bit tonight. So that's another learning objective. And then iteration, we talked a little bit about that in the first session. I will give an example of one type of iteration, a pattern of iteration tonight. Then also coming up ahead is branching and control flow. And then functions, we've started to expose you to built-in functions and functions that come with what are called libraries. But you also need to be able to write your own functions, and we're going to get into that. And then we'll sort of finally finish up with understanding the basics of debugging. Now, this is a first pass at really essentially all the core topics of programming. And if you get a good overview, good 10,000-foot understanding of these concepts, then you're going to be well on your way to mastering Python. Okay, so let's do a quick recap. And with primitive data and operations, and what we looked at last week, I'm not going to go through everything, but just the basic idea. So Guido von Rossum created Python on or about 1999, 2000. So Python has been around for about a quarter of a century, 25 years. So it's quite a mature programming language. So I invited you to consider a simplified view of Python. And this is important to understand how Python works from the ground up. And so on the first day of creation, Python, Guido created atoms, or what we can think of as atoms of the language. Now, Python means sort of two senses. There's the world of Python, Python objects, and then we use the Python language to perform operations and work on objects in the Python world. So here I'm now thinking about the Python world consisting of objects. And there are four basic atoms in the Python language, the Python world: int, float, string, and boolean. So this is something that should just flow out from you. You should know this, should be at the tip of your tongue all the time. The primitive objects in Python, the atoms of Python, are four: integer, float, string, and boolean. Having said that, I don't always speak the complete truth. So if you want the whole truth, there are actually six primitive objects, what are called complex. That stands for complex numbers, if you're familiar with complex numbers from engineering or mathematics. That's also part of the at the ground floor of the Python world. And then there's a peculiar data type called none, and those are there. And at some point down in the future, we might look at those two other types. But for all intents and purposes, for our sake, we want to focus on four. And these are the four: integer, float, string, and boolean that you really need to be familiar with. Okay, and what are examples of that? Integer is a numeric type, and it's a non-decimal number. And examples, I'm not going to read it to you. They're non-decimal numbers. Then we have float, which are decimal numbers, positive and negative. And then we have this somewhat peculiar data type object called boolean, and it only has two possible values: true or false. It's one or the other. And unlike float and int, they're uncountably many. You can have any sort of integer by the constraint of hardware, of course, but really any decimal number and integer is a possible value of data type int and float. But there are only two possible values for boolean: true or false. And then finally we have string, which is at the ground floor a character object, and examples of that are any sort of sequence of characters like Macbeth or cat on a hot tin roof. You can form a string, you can represent a string with quotes, either double quotes or single quotes. As long as you're consistent, if you begin a string with double quotes, you have to end with double quotes. If you begin it with a single quote, you have to end it with a single quote. Okay, so those are the four primary objects primitive objects in Python. I refer to them as atoms. And then we saw that we can perform a variety of operations on those atoms. And a initial working definition of a computation is an operation on data, where at the beginning we have these four data types: numbers, two classes, integer and float; character in the string data type; and then we have also boolean. And I've listed on the right-hand side examples of operations that you can perform on these data objects. So you should really become familiar with these fundamental operations that you can perform on the primitive data. Okay, so Guido created atoms during the first day of Python. He didn't rest. He went on the second day and he created molecules. And this is where the fun begins with the Python language. Not all that interesting to have integers and floats. Yeah, you can do computation of various sorts. Fun, but not all that interesting. Where the interesting aspects of Python comes in is creating these molecules, data structures, and these are called collections. And that's what we're going to look at tonight. And there are four principal collections in Python: list, tuple, set, and dictionary. So you want to kind of take this in, become really familiar with lists, tuple, sets, and dictionaries. And then we're going to see also what operations we can perform on these four collections. So now we're starting to get to the heart of Python. And also, if you're familiar with other programming languages, it's data structures that allow you to go to the molecular level, if you will, is going to be very, very critically important. Okay, now, one of the things that you're going to have to get your arms around is these collections have a set of properties. And there are three principal properties that you need to understand about collections. What are they? So first is each collection is either ordered or unordered. I'm going to explain that as we go, and we'll see it in action, but you want to keep this in mind. So a list is an example of an ordered collection. A tuple is also an ordered collection. A set and dictionaries, on the other hand, are unordered collections. So you want to try and understand what the meaning of ordered versus unordered collection is. And we'll take a look at that in just a minute. The other key distinction is between mutability and immutable. And that's fairly intuitively easy. A mutable collection is one where once you've created the collection or defined the collection, a mutable collection is one which you can either add new elements to the collection or delete elements from the collection. So in other words, you can change it, making it mutable. An immutable collection is one, once you've created it, you can't change it. You can't delete elements or items from the collection nor add to it. And tuple is the only example of a immutable collection among the four. Then I've also listed another property. It's going to turn out that it's between heterogeneous and homogeneous. All four of the ones that we're going to look at and are part of the Python standard library are heterogeneous, meaning contrast that with homogeneous. So what that means is the collection can consist of different data types. You can mix character, you can add character or string, Boolean. If it's heterogeneous, you can add different data types into the collection. Homogeneous, you can only add or have as part of the collection, as elements of the collection, one data type. And the most important example of this is going to be, we're not going to confront it tonight or even in the set of sessions, but if you study Python for data science and machine learning, which are going to be dealing with quite a bit, are arrays and matrices. And arrays and matrices, NumPy library in Python is a very, very important computational library, and it only works on numerical data. And in that sense, the data type of a matrix or an array, for example, in the NumPy library, it's homogeneous. You can't add Boolean or character data elements to that data type. Okay, so I've said a lot, but I wanted to have on one slide three important properties of collections: ordered versus unordered, mutable versus immutable, and then homogeneous versus heterogeneous. Okay. All right. So now let's code Python. So I'm going to go into Visual Studio Code, and this should be familiar to you. And let me just pause here for 1 second. Okay, so we're in Visual Studio Code. I've already gone into a folder that I'll be working in. I will click off the Welcome tab, and now I'm ready to open up a folder, or since I'm already in a folder, I'm just going to go ahead and start a new Python file. All right, so I'm going to click on New Python, New File. I'm going to give the file a name. So let's call this list example.py. And that brings up a file where I can start typing a Python program. Okay, so what we want to do in this particular program is just look at some list basics. Okay, so first is how do we create a list? So a list is a collection. It's going to be an ordered collection, which we'll get to in just a minute. But how do I define a new list? Well, suppose I wanted to track for some reason a list of countries. So I'm going to create a variable called countries. And the way I create a list is I use square brackets. So a list begins with a square bracket and ends with a square bracket. And then each item in the list is separated by a comma. So I'm going to create a list of countries, and since countries is a character object, I'm going to use a string object. That will be my first element. So let's have Ireland as one of the elements of the list. Then let's add Japan, Venezuela, and let's add one more. Okay, so I'll hit return. And now we should have defined a list. And we created the list using square brackets. We have should have four elements in the list called countries. Let's go ahead and print the list and comma length of countries. And length is a Python function. When you insert it, if you give as an argument a certain type of object, it will tell you the length of that object. Okay, so let's just go ahead and run this program. I'll hit on the run button or execute button, and down below it opens up the terminal window, and we can see that down below it's printed the list and tells me that the length of the list is 4. All right, so we've created a list. Let me clear my terminal window. Okay, so we've created a list and printed out the list, gotten its length. A list is mutable, means I can add new elements to the list. So let's just go ahead and do that. I have a list called countries. Let's add an element to my list of countries. And the way to do that is I give the name of the list and used what's called a method, the append method. So I'm going to append or add an element to that list. What are we going to add? Let's add a new country, Iceland. Okay, and then it will go on to the next. And let me just add a comment here, print list of countries. Print list and length of countries. Let me just go ahead and save this file and now run it again. And so now we have a new list, or we've changed the list. We started by creating a list with 4 elements. We added or appended an element to that list. And now our new list, updated list of countries, has 5 elements. Okay, mutability also means we can delete items from the list. And I'm going to skip that part tonight. I'll leave that for you as kind of homework. Figure out how I can remove a particular element from the list. All right. There's this idea of also, suppose you have two lists, and I don't want to add just an element to a list, but I want to put two lists together. All right, so how do I do that? So let me create a new list. Let's call it even. And this is going to stand for the list of even numbers. So we'll start with 2, 4, 6, 8. Let's create odd for odd numbers, and we'll have 1, 3, 5, 7, 9. So I've created two lists here, one for even numbers, one for odd numbers. You create a list using square brackets. Each element in the list is separated by a comma. Now, I'm going to create a new list called NN, and NN standing for natural numbers. I want to take the list of even numbers and extend that with the list of odd numbers, essentially joining the two. And I can do it in several different ways, but we're going to start with the even numbers and extend it by adding another list to it. Okay, and now let's print the result. Let me see what's going on here for a second. Let me start just a new file so I get this other stuff out of the way. Just going to copy this, start a new file, extend example.py, and let's first just start with even and odd and print that out. Let me comment out. Okay, so we have the list of even numbers and the list of odd numbers. And let me just print first. It's giving me none, which is strange. Okay, I'm not sure why it's not working. Let me try. Oh, that can't be right. Okay, I'm not sure why this is not working. So this will be a good exercise in debugging. So I'll kind of leave this to you to research. It's one of the privileges that I have. If I can't figure out what's going on, I'll let you do some research on it. There should be, the extend method should allow us to take a string and extend it. All right, this is bugging me. All right, for tonight, just let's go with the idea of creating a list. It's a mutable, meaning I can add elements to it. I can also delete elements from it. Now let's get to the idea of heterogeneity. Let me come back to our earlier list. Let's get rid of this. So we have a list of countries, but suppose I wanted to add a number to that list. So I'm going to say countries append, and let's do it above it so I don't have to do another print statement, and run it again. And so this is perfectly allowed, even though a number is not a country. I've added, let me run this again so we can see it. This list consists of string elements, as well as I added a number 3.14159. Okay, so a list is a heterogeneous object, meaning I can add different data types to it. And the ones that we're familiar with so far are int, float, boolean, and string. All right, so what about boolean to it? We should be able to. I'll do append, and let's add true. So true is one of the possible values for boolean, and let's add that. And we see now our list has been expanded to 7 elements. It consists of both string elements. We have a float, and then we have a Boolean value. All right, now let's get to another critical aspect of the list data object or data structure, and that's the idea of ordered. We say it's an ordered collection. So there are 2 types of collections, ordered and unordered. And if it's an order, so one way to visualize it, the way I visualize an ordered collection versus an unordered collection is, an unordered collection is I just think of it as a bag full of elements. They have no order. And by order, we mean if a collection is ordered, there's this idea of something before some element and something after another element. Just like a set of numbers. A set of numbers can be either thought of as an ordered collection, as a set, or an ordered collection. And so the set of natural numbers is an ordered collection where the number 2 comes after the number 1, but is before the number 3. So an ordered collection, each element has a position in the collection. And that position is marked by its index. And one of the characteristics, so think of this as a line. When you're waiting in line for a concert ticket for Britney Swift, you're first in line or 10th in line or 100th in line. And people get annoyed when they don't know where their position is. They think they're in line, but they don't know where the position is or their index. Now in Python, index begins at 0. So if you're the first person in line, your index, your position is 0. So Python as a language starts with index 0. Okay, so we have the list of countries, and if we were to type or obtain the value that corresponds to the first element in the list of countries, the way to obtain that is to use the index 0 in square brackets. And now let's run this program, and what it returns is Ireland. Ireland indeed is the first element in the list. Its position is 0. Its index is 0. If we do 3, and let's print that out, it's Zimbabwe. Now Zimbabwe is the 4th element in the list, but its index is 3 because we begin with 0, then there's 1, 2, 3. So we want to keep that in mind. But the point here is ordered collections have an order, meaning elements have a position in the collection, and their position is indicated by its index. I'm going to make one other point about lists before we go on to the other collection examples. You can have the same element appear multiple times in the list. Okay, so I'm going to go back here and let's add one more item. We're going to add append, and let's add Iceland again. And let me comment this out for 1 second. Let's run this. Okay, so now let's just take a quick look at the list. We started with a list with 4 elements: Ireland, Japan, Venezuela, Zimbabwe. We added a 5th element, Iceland, also a string. Then we added a number, a float, then Boolean, and then we added Iceland again, and then we printed out the result. And if we look below, what we have is Iceland appears twice on the list, right? So you could have the same object appear multiple times in the list. All right, and that's perfectly permissible. And we're going to contrast that with a set in just a minute. So just going to keep that in mind. We can have the same object appear multiple times in the list. I was going to stop there with lists, but I'm just going to throw you one more wrinkle and one more example. Let's create a list called pair, and it will have the numbers 3 and 4. And now let's add to our list not a single primitive data type, but another list. So I'm going to append pair to it, and let's see what the result is. Okay, so when we look at the new list at the end, we started off with Ireland, Zimbabwe, etc. Then we added float, Boolean, Iceland, and then the next thing that appears is not a primitive object, but another list. So you can have a nested list, a list within a list, and that can go down quite deep. Now you got to be careful about that because it can be confusing. It can mess up your program, but it's allowable. You can have nested lists where you can have an element in a list which itself is a list. Okay, so that's kind of a very, very basic introduction to lists. Now let's look at tuples. And I'm not going to go too far into tuples, except in every way they're similar to a list. The only difference between a list and a tuple is that a tuple is immutable, means once you create it, you can't change it. So a natural question is, why would you want to create a tuple as opposed to a list? So let's do a tuple example. All right, so I'm going to suppose we're creating a program to play poker, and you need to create a card deck. Well, I could use a list, but let's start with, we're going to create a list of suits. And I'm not a card player, so I always get suits and ranks mixed up. So hopefully this is right. Let me create a tuple. Now, if we were to have created a list, I would have used square brackets, and we could have done that. But I've chosen to create a tuple, and the only difference is we'll get to that in a minute, but the way to create a tuple is to use parentheses, and that's how you create a tuple. All right, so now this is missing one of the suits, but let's just go ahead and print that out. Let's print suits, and then let's check the type of suits, and also let's print out its length. Let me clear the terminal window. Let's run this, and I have a tuple with 3 elements: clubs, diamonds, hearts. Now let's try to add, I'm missing a suit, so let's add a pen. Maybe this will work. A spades, I don't know. Okay, so spades, and let me run this. Nope, I get an error. The reason why we get this error is a tuple is immutable. Once you've created a tuple, you can't change it. So why might you want to create a tuple? 2 reasons. Well, first, the background reason is if you have a collection and you needed an ordered collection or a collection that doesn't change, that's not going to change, you're not going to touch it, kind of equivalent to a constant, but for a collection, then a tuple is a good candidate. For reasons, one of the primary reasons is it's going to save you money. The way computers allocate memory, the more predictability it is. If it knows that you're never going to change this data element, it can optimize the amount of storage and memory that it has to create. Whereas if you're going to change constantly and adding things to a particular variable, then there's a lot more overhead involved in memory management. So a tuple is a good candidate for when you need a collection, particularly an ordered collection that's not likely to change, that you don't plan on changing. Now there are tricks that you can play around that, but kind of keep that in mind. So I'm going to stop there with tuple. It works exactly like a list. It has this idea of order, it has indices, and so on. But once you created a tuple, you can't change it. All right. Now let's get to the next item in our collections, and that's a set. I'm not going to say too much about sets, but they're very, very powerful, and you should definitely know how to create it and add things to it and so on. So let's create a set example, and let's create, as earlier, odd, standing for odd numbers. Okay, so the way to create a set is now using braces or squiggly brackets. And let's create the set of even numbers. And let's print odd and print even. Okay, let's create one more example. We're going to create the set of primes. Is 1 a prime number or not? I don't think it is. The next one is 11, 13, 17. All right. Okay, so I've created 3 sets: odd numbers, even numbers, and prime numbers. Sets are mutable, meaning I can add new elements to that. I'm not going to go over that today, but you should look that up. The operations that you can perform on sets are extremely powerful. I'm going to come to a slide in just a minute to give you a sense of that power. But one of the things that we can do with sets is perform set operations. And those are things like union, intersection, and so on. So how would we go about doing that? Well, we have this set of odd numbers, and if we want to take the intersection, well, let's go with this first, odd or even, and let's print that out. And let me print out. Okay, so let's just pause and look at this. Let me clear my terminal window. Okay, so what's going on? We created 3 sets: odd, even, primes. Print those out. This is the OR operator. But what's OR? That's union. When I say A or B, when it comes to sets, it's performs a union operation. So when I print that out, odd or even, I'm combining those 2 sets. So the result is every element in odd and union every element in even. When I say odd and even, that's intersection. And so when I take the intersection of set odd and even, I get the empty set. There's no intersection. Let's do one more example. Suppose I take the union, not union, but intersection of the prime numbers, primes, and odd. Let's see what the result of that is. So union of odd numbers and primes is 11, 3, 5, and 7. If I take the union of primes and even, I'll get the empty set. I'm going to just show you a slide deck. I'm going to say, well, what good is all this stuff? Set operations are extremely powerful, and there are a lot of things that you can do with it, especially on the data analysis side, if you know how to work with sets. And the operators are quite simple once you get used to it. So I'm not going to go through this whole slide deck, but just kind of give you a flavor of it. So these are the most common operations in sets. So anytime you have collections, you can transform it into sets and perform these types of operations. So I gave you an example of intersection, union. Sometimes you want to know difference, meaning is some what elements are in one set but not the other. There's something called symmetric difference, subset. There's complements, and these are just visual examples of set operations. Union, when combining the two sets. Difference. This is called symmetric difference or disjunctive union. A complement, subset, and so on. So now, suppose you have two sets. You have a set of countries, and then you have a set of countries that won Olympic medals in the Summer Games, and then you have another set who won Olympic medals in the Winter Games. And there are all kinds of questions that you can ask. Let's see where I get to the questions. Yeah. So these are some questions that you might want to ask. Which countries won medals in Summer and Winter Olympics, both Olympics? Which countries won medals in the Summer or Winter Olympic Games, but not both? Which countries didn't win any medal in the Summer Olympics, didn't win any in the Winter Olympics? Which countries? Good luck trying to create a query language to answer these types of questions. Your brain's gonna go on, will spin around, or at least I have a really difficult time using something like query language to get at these types of questions. But if you are proficient using set operations, you can very easily and quickly answer these questions. And part of the technique there is your starting point might be a list, or it might be a tuple, it might even have a dictionary. And if you can bring it into and make it into a set, then you can answer these types of questions very, very quickly using set operations. So I wanted to kind of give you that. Now let's turn to the final example, and that's a dictionary. Okay, so dictionaries. Now, dictionaries are incredibly powerful. They're one of the most underrated data structures, but if you're a computer scientist, you're really familiar with them and know their power. And I'm just going to give you some examples of how they work in just a minute. But one big intuitive idea behind, let me clear my terminal, just to motivate how and why they're important. Suppose you have a list of all the books in your library. But let's take an example where the list is quite large, very, very large. How about all the URLs on the World Wide Web? Okay. And you need to do search. And you're sitting around at Stanford University and thinking of something like search on something like the World Wide Web. It hasn't grown that much yet, but it's still a challenging problem of how would I implement search to search every website, every URL, and find a word or a set of words. Oh, well, if you are only familiar with a data structure such as a list, the way lists work is if I have a list and I need to search within that list, I'm going to go through sequentially in order, one element at a time, until I find what I'm looking for. And if it happens to be the case that what I'm looking for in the list is at the end of the list, I'm going to have to wait forever to, especially if it's a very long list, get to the end of the list, and I might be waiting forever. All right. So not a very efficient data structure for a number of tasks. And a dictionary, the reason why it's called a dictionary is, what's a dictionary? A dictionary, you have a word, and corresponding to the word is the definition. So if I have the word, I look up the meaning of the word corresponding to the word, right? Now, the way a dictionary works, it's called a key value pair, and I'll show you an example, shows examples in just a minute, but I can go straight to the meaning of the word. I don't have to go through sequentially. Imagine if in order to use a dictionary, you had to go through the first word in the dictionary until you got to the word that you were looking for. And that's the way data structures like lists work. Whereas if you have a data structure set up as a dictionary, I can go to the value of the key right away. Okay, so they're hyper fast and hyper optimized for things like search. So very, very important data structure to get to know. So let's do some examples of a dictionary. Okay, so we're going to define a dictionary, and we're going to call this, suppose I wanted to have call it a database, if you will, of all the books in my library. So I'm going to call it a lib. We're going to create a dictionary, and the way we create a dictionary is we use the same parentheses as we do for creating a set. However, we're creating now a dictionary. And the way we create a dictionary is we provide what's called a set of key value pairs. Okay. So a dictionary is a set of key value pairs. So the first thing I define when I create a dictionary is a key. So suppose I'm going to create my dictionary of my library dictionary based on author, and that's the key. And if I give the dictionary the key Austen, it's going to give back the value, a book that Jane Austen wrote. And so persuasion, spell it right. So I've entered one key value pair in my dictionary. So now let's say that I have a book by Borges, and the name of the book is Ficciones. Okay, so this dictionary has two elements, two key value pairs. The key is the author, the value, lookup value is the book. So this is how I create a dictionary. This is a very, very simple example. Now let's assuming I've created this dictionary called lib, let's give it a key and let's print it out. And let me run this. Okay. So we have created a dictionary. Now I'm looking up. It's a key value pair, a set of key value pairs. When I provide the dictionary the key, it returns the value, persuasion. Now, it's very likely that if you're a Jane Austen fan, you're not going to have just one book. So how might I create the key as the author, and the value is the set of books or the list of books that I have in my library. So I might have Emma. What else did Jane Austen write? Pride and Prejudice, and so on. All right, let's see if this works. So I've created a dictionary. Key is the author. First item in the dictionary. I said first. Now, a dictionary is unordered. So there is no index corresponding to a dictionary. So it's like a set, it's unordered. But if I provide a key, it should return the value. So let's do lib Austen again, and this time it returns a list, okay? If I were to give the key Borges, then it returns Ficciones. Okay, if I were to provide a key that's not in the dictionary, so let's do Joyce, it's going to come back with a key error. All right, now there are ways to work on that but the main idea is that a dictionary is a key value pair, very, very powerful data structure, very hyper efficient. You could have a huge amount of elements in the dictionary and it will find the thing very, very quickly. So very, very important data structure to get to know. I'm going to, let's just stop here. I will go over kind of some next steps.